All right, so we're going to have a review here because on Friday we're going to have our quadratics test. So keep an eye out for that. But we have 3 days to review before then, so it should be a good one. For this first group, it's all about the imaginary number I, and remember that I squared is equal to negative 1. If you remember that, then that makes the rest of this pretty easy. So remember, there's nothing in between the parentheses, that's when you multiply. So you'll multiply those two together and then distribute that into this last set of parentheses. So we have 8 times 3 is 24, and then I times I gives you I squared. Now before you go and distribute that, what I would do is change that I squared into negative 1, which is going to turn 24 into negative 24, and then we'll distribute negative 24 and get our answer. So all you got to do is multiply that. 24 in there, so negative 24 times 8 is going to be negative 192, and negative 24 times the 3 is going to be negative 72i. And there we have simplified the first one. So finish the rest of those. Remember, when you have two binomials to distribute both pieces, and remember that number 4, when you have a square, you're multiplying by itself, so you'll write it out twice. So we have negative 6 plus 4i, negative 6 plus 4i. Write it twice, and then distribute just like number 2. When you go down to numbers 5 and 6, there's a minus sign in between the parentheses, so you're not multiplying anymore. So that minus has to change your signs inside the parenthesis and then combine like terms. So there's nothing in front of the first set, so you can drop the parentheses, combine the i's, and then combine the numbers. So we have negative 6i, giving you negative 12i, and then negative 5, and then positive 6, giving you positive 1. So those are easy. Just distribute the negative if you have to. But if there's a positive in front of the parenthesis instead, then you wouldn't distribute anything. You would just drop the parentheses and combine like terms. I'm going to go to factor completely. Don't forget to take out a common factor if you can. So check all 3 of the numbers. Can they all be divided by something? Number 7 here, the first number is a 7, so you can only divide by 7. 55 isn't going to divide by 7, so you can't do a 7. But they all have a k, right? So you can divide out a k, factor out a k. And the k goes in front of the parentheses, and the exponents each get dropped by 1. So this is going to be 7k to the second plus 55k to the first, and then plus 42, and that k goes away because it is pulled out to the front. So that k in front is not going to do anything from here, but it does need to get dropped down every time. But now we can factor the rest of it using the star. So remember, a times c goes on the top, b goes on the bottom, and a goes on the bottom sides. And a, b, and c are just like we've always done. So here's our a number, there's our c. So do 7 times 42. And that's going to give us 294 on top. B is 55. He goes on the bottom. 7 goes on the bottom sides. So now we're looking for a number that multiplies to get 294 and adds to get 55. When it's a high number like that, I just start dividing by things, and I start low. So 294, we'll divide it by 2 just so we don't miss anything. So we got 2 times 147. 2 times 147 is not going to add to get 55. I guess I should put a plus sign in there. So I divided 294 by 2 and got 197. That's where those are coming from. But 2 plus 147 is going to be far too big, right? We're looking to get 55. So then I take 294 divided by 3. So 3 and 98. So 294 divided by 3 gives me 98. But 98 plus 3 is still going to be too big, but it's getting closer. So if I was doing this without explaining it, I would have skipped ahead. I wouldn't even try 2 and 3. But so now skip a little bit. I don't know. Let's try 6. So I divided it by 6, and I got 49. So 6 plus 49. Look at that. That's going to be 55. So 6 and 49 are the pair that I'm looking for. Now I just have to make sure that the negatives work. And I'm multiplying to get a positive 294. Positive times positive is positive, but I want to add to get a positive 55. So 6 plus 49 is a positive 55, so that's good. Okay, then the last thing we want to do is simplify if we can. 6 over 7 does not, but 49 over 7 goes down to 7 over 1. And then that will give us our factors. So drop the k down, and then the 6 over 7, the 7 goes first, so we have 7k plus 6, and then the 7 over 1, we have 1k plus 7. And there we have factored completely. All right, so that's the process. Okay, solving quadratic equations. Remember, you have options. You could solve by graphing and look for where they cross the x-axis. You could solve with factoring or the quadratic formula. And I would recommend you start with factoring. So start with factoring, and then if that doesn't work, do the quadratic formula. The quadratic formula will solve anything, but factoring will only solve it if it's factorable. But I think you will find it easier to do it by factoring. Now remember, it has to be equal to 0 first, no matter which way you go. And then once it's equal to 0, you factor and set the factors equal to 0. So like number 13, let's do that one instead, because it's not equal to 0. So I'm going to move that negative 65 over, and it's negative 65x, so it's my b term. So I'm going to put it in the middle, the 21x squared, and then positive 65x, because the sign has to change, plus 24, and now it's equal to 0. So the first thing that you want to do is factor a common factor if you can, because that's going to make the factoring with the star a lot easier. Now, unfortunately, 65 can only be divided by 5 and 13, and neither of those are going into 21 or 24. So we have to multiply 21 times 24 to put into the star. So that's 504. And then 65 on the bottom and 21 on the sides. So you take 504 and start dividing by things. I'm going to start with 4. So if I divide it by 4, I get 126. If I add those, I'm not getting to 65. Right? I want to multiply to get 504 and add to get 65. So I'm going to skip ahead a little bit. I don't know, I'll divide by 8. So if I divide by 8, I get 63. That's getting closer. So that's only, 71. So that's pretty close. So that means the number I'm looking for is pretty close to 8. So let's divide it by 9. Okay, so 9, if I divide by 9, I get 56. 9 plus 56 is going to be 65. So that's what I'm looking for, 9 and 56. I make sure the signs work, and they do. And then all I have to do is simplify the fraction. So 9 and 21 can both be divided by 3. If I divide them by 3, I get 3 and 7. 56 and 21 can both be divided by 7. I get 8 and 3. So there's my fractions, which give me my factors. So this 3 over 7 gives me 7x plus 3, and 8 over 3 is 3x plus 8. And then I set them both equal to 0 and solve. So I subtract the 3, get negative 3 equals 7x, divide by 7, and there's my answer, negative 3 over 7. Okay. Now you might notice that that is the opposite of the fraction that we got on the sides, which is always going to be the case. If you remember to switch it, then you can skip setting it equal to 0, but you have to switch it. So negative 8 equals 3x. X is negative 8 over 3. So there's my two solutions. Okay, so finish up the rest of those. If you cannot solve it by factoring, if it doesn't actually factor, then you have to do the quadratic formula. And you will see two of them on the back here that are like that. Okay, so work hard on this, do your own work on it. If you have any questions, make sure you ask. But remember, the test over this will be this Friday.